Hello. Who are you? I'm Glinda, the good witch of Oz.
Who was that?
That was the wicked witch of the north.
Where did she take Mittens?
She took Mittens to the gates of Oz.
How do I get there?
Take this compass.
Okay.
The north end of this compass always points in the direction of the magnetic field. You need to follow the magnetic field to get to Oz.
Okay. Right here?
Yeah, that's correct.
Okay. Thank you.
You're welcome.
Goodbye.
Bye. Hello, I'm Archimedes. What can I help you with?
I need to get to the key to get into Oz.
Well, that's at the bottom of the pool.
How do I get to the bottom of the pool?
To do that, you need to calculate the buoyant force to figure out with which velocity you need to enter the pool with. Luckily, I'm the expert at the buoyant force.
Can you help me?
Yes. Let me show you. To find the velocity needed to enter the pool to reach the key, which is 3 meters below the surface, we first need to calculate the buoyant force. The buoyant force is equal to the weight of the displaced fluid, which is equal to the density of the fluid times the volume of the fluid displaced times g. The density of the fluid is 1,000 kilograms per meter cubed. The volume of the fluid displaced is 0.1 meter cubed, and g is 9.8 meters per second squared. After we calculate this, we get 980 newtons. We also need to find the weight of the diver, which is equal to mg. The weight of the diver is 60, the mass of the diver is 60 kilograms, and g is 9.8 meters per second squared. We get the weight of the diver to be 588 newtons. To find the acceleration of the diver after she enters the water, we can do some of the forces. The buoyant force is acting up on the diver, and the force of gravity is acting down. And we get the acceleration to be 6.5 meters per second squared in the upward direction. So then we can find the initial velocity needed. The final velocity is 0 meters per second. The acceleration is negative 6.5 meters per second squared because it's in the up direction, and delta y is 3 meters. We can use the formula bf squared equals bi squared plus 2a delta y. We get the initial velocity to be 6.2 meters per second. So the diver needs to enter the water at 6.2 meters per second to reach the key.
Please excuse this interruption.
Hi, I'm Kim Maddox, attorney at law. At the physics firm, we specialize in assisting clients who've sustained injuries while experimenting with new physics concepts or performing labs in physics class. If you or a lab partner has been affected by physics injuries, call us today.
One day I was walking into room 523 to deliver a nice steaming cup of coffee to Mr. Big. As I walked through the door, one of his reckless students collided with me. It was a perfectly inelastic collision. Not only did I break a rib, but I also sustained third-degree burns. Thanks to the physics firm, I received a settlement for a new cup of coffee and a brand new physics book. Thanks, physics firm.
Since my classroom is across the hall from Mr. Big's physics class, I constantly have to go over there and tell the students to quiet down. One day, I marched across the hall to demand some peace and quiet. As soon as I walked in the door, I got hit immediately by a heavy object in a perfectly elastic collision. Thankfully, I called the physics firm, and they got me a free pair of polarized sunglasses and an inertia club card. Thanks, Kinematics.
Are we the only Rochester law firm who specializes in physics class injuries? No. Are we the best? You bet.
I was assisting physics students in room 523 during one of my free periods. They were performing a centripetal force lab in which rubber stoppers were violently whirled around their heads. As I was making my way around the room, I was hit in the head, resulting in a serious concussion. Then I fell on the floor and broke my arm. Thanks to the physics firm, I received a settlement of 3 free physics textbooks.
When two objects undergo a perfectly elastic collision, kinetic energy as well as momentum is conserved. Kinetic energy is the energy of motion, and momentum is the resistance of an object to the stopping of motion. Mrs. Kress experienced this type of collision when an object hit her and bounced off of her. You can calculate the velocity or mass of any part of the system by setting the initial kinetic energy equal to the final kinetic energy, or the initial momentum equal to the final momentum. When two objects undergo a perfectly inelastic collision, the objects stick together. Only momentum is conserved. This type of collision Mr. Johnson experienced. You can set the initial momentum equal to the final momentum to solve for the mass or the velocity. When an object undergoes an explosion, the object separates. Only momentum is conserved. The law of conservation of momentum always holds true for elastic collisions, inelastic collisions, and explosions. However, if two objects are not experiencing a perfectly elastic collision, kinetic energy is often converted into other forms of energy.
We've settled all sorts of injuries. Concussions from rubber stoppers, shocks from Van der Graafs, vision damage from laser beams, injuries from falling objects due to gravity, self-inflicted injuries as a result of the extreme frustration in understanding quantum mechanics. What are you waiting for? Call the physics firm, 1-800-PHYSICS. That's 1-800-749-7427. Call us today.
Now back to our feature presentation.